Hi, physical science classes. Today you're watching a video of 2.5b notes. During this video, I want you to do the following two things. A, write the problems down as another example. B, answer the questions at the end of the video on that same piece of paper and bring that to class. So let's get started. First example, you're given two cars. Car A, going to the right at 5 meters per second, has a mass of 1,000 kilograms. Car B, going to the left, has a mass of 2,000 kilograms and is moving at 2 meters per second. Crunch. After the collision, car A still has a 1,000 kilogram mass and is now moving to the right at 3 meters per second. Car B still has a mass of 2,000 kilograms. What direction is its velocity? And what is its velocity? So we're going to start answering all four parts to this question. The first part of the question is, what type of collision is this? Remember that you know what type of collision it is based on how many things you have before and after. Notice that you have two things before and two things after. This would be an elastic collision. Now we're going to find the momentum before or after. You find the momentum based on, do you have all the information in the problem? So we're able in this problem to find the momentum before. Now there are two different objects, so I'm going to find two momentums and add them together. The first car has a momentum of 5,000 kilogram meters per second. The second car has a momentum of negative 4,000 kilogram meters per second. And the reason it's negative is because it is going to the left. Therefore, the total momentum before should be 1,000 kilogram meter per second. The total momentum before should be 1,000 kilogram meters per second. So if we know the total momentum before, we can then find the total momentum after, because of the law of conservation of momentum says that it should be the same, 1,000 kilogram meters per second. Now, if you are only comfortable doing level C, you can stop. But let's go ahead and do level D, because there are some of us that need this. In this side, the after side, notice that we have the information for the A car. So the A car's momentum should be 3,000 kilogram meters per second, because it is moving at 3 meters per second in the positive direction. That does mean that if the total momentum is 1,000 and this part is 3,000, that means that the momentum P of the B car is negative 2,000 kilogram meters per second. The momentum of the B car, this car here, and I'll put a star by that. This car right here has a momentum of negative 2,000 kilogram meters per second. So to find its velocity would equal its momentum divided by its mass. Well, its momentum is negative 2,000 kilogram meters per second, and its mass is 2,000 kilograms, making its velocity be a negative 1 meter per second. that means that it's going to try to go to the left at 1 meter per second. Now let's move on to example 2. Again, example 2, notice what you have. You have a truck that someone has put a bomb in, and it goes kaboom. And you have pieces of this truck that are flying. So the first thing you have to do is identify the type of the collision. Type of collision here should be inelastic because you had one item before and now you have two parts to that item. This would be inelastic. Now, looking at the problem, the only place you have all of the information is in the before. So we're going to calculate the momentum before. Grabbing a calculator, the momentum is the mass, 2512 kilograms, times its velocity of 11.2 meters per second, gives us a momentum of 28,134.4 kilogram meters per second. And if that's the momentum before, that has to be the same momentum after 28,134.4 kilogram meters per second. So if that is before and after, notice that we have part A of the car, the back of the car. We can actually find its momentum because we have its mass and its velocity. So let's do that. Its momentum should be 1122 times 5.36, and it is a negative 6,013.92. So if this side is a negative 6,013.92 because it's going to the left, what is this one? Well, notice I've asked you two questions. What is the mass and the velocity of the B car? The mass is easy to find. Take the total mass of 2512 and subtract the mass of the back, 1122. That should give you a mass of the B section of 1390 kilograms. Now we need to look at the velocity. Well, velocity, remember, is momentum divided by mass. But the momentum we need is not the total momentum, it's just the momentum of the B section of the car. If this is the momentum, this 6,000 number, is the momentum of the A car, notice it is negative, the momentum of the B car can be found by taking 28,134.4 and adding 6,013.92. The reason we add them is because we need this total momentum total momentum after to equal this number. If part of it is negative, this number has to be bigger. So the total momentum of the B section should be 34,148.32 kilogram meters per second. So when we come down here to find the velocity, we're going to use the total momentum of the B section, 34,148.32, divided by the mass of the B section, 1390, and that will give us the total velocity of the B car, which should be 24.57 meters per second to the right. All right, there's your examples. Now let's answer some questions. Question 1. How can you tell what type of collision has happened? Question 2. What does conservation of momentum mean? Be sure to bring these back with you next class. Thanks for watching.